Hello everybody. On the notes that we have for today, we're going to be talking about 4.4, which are linear transformations. Our learning target is I can determine the effects of transformations on the graph of a linear function in two variables with and without technology using precise mathematical language and notation. I can analyze relationships to make sense of problems. So when we talk about transformations, I believe you talked about transformations a little bit in middle school, but you were doing transformations with like shapes like triangles and circles and things of that nature. We are going to be focusing transformations on our linear functions because, as I said in an earlier video, Unit 4 is another linear unit for us. So we are going to be taking our linear functions, our lines, and we are going to be applying transformations to our lines. Okay, there are a couple of different vocab words that we have. The first vocab word that we have is a transformation, and a transformation is just the movement of a line on a coordinate plane, or a graph, if you will. There are many different types of transformations that we can have. We can have a translation, a reflection, a stretch, or a compression. And a translation is probably the one that you know best and will be the easiest for you to accomplish. And this is where you take a line and you shift it up, down, left, or right on a graph. So we're going to go up, down, left, or right. These movements do not change the slope of the line. So if I take a line like this and I say we're going to shift this to the right 5 units, you're literally going to take that line to the right, and the line is still going to have the same slope. It's just going to be over 5 units to the right on your graph. There was no change in the steepness of your graph. Okay. Gross. Another transformation that you can have is a reflection, and the easiest way to think of a reflection is by flipping a line over another line. And in Algebra 1, we focus primarily on doing reflections over the axes. So this is the x-axis and the y-axis. However, you can do a reflection over many different types of lines. But like I said, in Algebra 1, we will focus mainly on the x-axis and y-axis. When you do a reflection over the x-axis and the y-axis, it will change the slope of the line. And then we can have a stretch or a compression. A stretch is to extend or make longer. And then a compression is to shrink or make shorter. And there are two different types of stretch and compressions we can have. We can have vertical stretch and compressions, and we can have horizontal stretch and compressions. And they're going to be a little bit different. They're going to look a little bit different from each other, and how we determine whether we have a vertical or a horizontal stretch / compression will be different. Okay. All right, we're going to talk about the easier things first, which are vertical translation. So remember, vertical is up and down. So when you think of a vertical translation, I want you to think we are shifting our graph up or down. Those are our only options, okay? So it says vertical translation, shift your graph up and down using the linear parent function f of x equals x, which is already graphed on these graphs below. And Desmos, I want you to determine the effects on the graph based on the transformation equation g of x. So what you're looking at right now is you are looking at f of x equals x graphed, okay? Remember that f of x is just what we use in place of y to show function notation. So this is the equation y equals x. Y equals x has a y-intercept at 0 and a slope of 1 over 1. So I've already graphed that for you so that you don't have to worry about graphing that every time, because it's kind of a pain in the butt to do that every time. Now, what we're telling you to do is we are telling you to have this other equation. It's called the transformation equation. We're going to call it g of x. And what this is telling us to do is it's telling us to take our original graph and then we're going to do something to it. Okay, this says we're taking the original and we're adding 2. So let's go to Desmos and I'm going to show you what this looks like. We're just going to do practice. Okay, so I'm going to come to Desmos and I'm going to type in f of x equals x, because that was the parent function that they wanted me to look at. When you look at Desmos, obviously the parent equation is a red graph. It has a y-intercept at 0, and I'm going to do a little, making this look a little bit nicer. There you go. And now you can see that this graph has a slope of 1 over 1. They're telling us to take our original, and we're going to call this g of x. You can really call it whatever you want. You just can't call it f of x again. They're telling us to take our original graph, which was f of x, and we're going to add 2 to it. Let's see what that does to our graph. So if I take my original graph, which is the red one, and then I add 2 to the back of that equation, it takes my graph and it shifts it up 2 places, which is kind of cool. So if we go back here, what's happening is we are going to have a graph that is 2 units above our original. Okay, so here we've got our new equation or our new graph, and it is up 2 units. So when it says determine the effects on the graph, you will say that your graph has shifted up 2. That's what I want, up 2. Now, without looking at Desmos, we're going to do something very similar. It says let g of x equal f of x. Remember that f of x stands for the original. And now I'm supposed to subtract 3 from that. So take a second, and without me showing you right away, you can pause the video here, but what I want you to do is I want you to think about, if plus 2 means that I'm going up 2, what do you think minus 3 means? Let's check it out in Desmos. So I'm keeping the same equations that I have, but I'm going to subtract the plus 2, and now I'm going to do minus 3. And if you said it shifts the graph down 3, you would be correct. So this is going to be down 3, and remember that our slope has not changed. So I'm going to look at my graph, and I'm going to go down 3 units, but I still have a slope of 1 over 1. I still have a slope of 1 over 1. And so that is going to be what my new graph looks like. So if you have a number at the back of f of x, out of parentheses, just hanging on to the back, it's going to do what you think it's going to do. It's going to shift your graph up or down depending on if you have a positive value or a negative value. Horizontal translations are translations that shift your graph left and right. So this is going to be, I'm going to do this in blue. This is left and right. Okay. It says using the linear parent function f of x equals x, which is already graphed, and Desmos, determine the effects on the graph based on the transformation equation. I'm actually going to change this a little bit because it's very, very difficult to see with our linear function. And so I'm actually going to change this to our quadratic function. So I'm actually going to come over here and I'm going to change this from x to x squared. Okay. So now you can see that this is a parabola. You'll learn about parabolas later, but this is a quadratic parent function, okay? So what we're going to do is now notice that you have something on the inside with x, whereas up here, we had a number that was not inside the parentheses with x. It was just hanging out in the back, okay? So now there's something inside of the parentheses with x, okay? We are still taking our original and we are doing something to it. Okay, and we have to determine what that is. So now that my number is inside with x, inside of parentheses, let's just kind of see what will happen when I type this back in over here. So this will be g of x equals f of x minus 3. Is that what I had? Let me go back and see. Yeah, minus 2. I guess it doesn't really matter. Minus 2. Okay. So I had, the red one was my original, that was my parent function. And then when I put something in parentheses, now instead of going up and down, we are looking at shifting things left and right. Well, if I have x minus 2 in the parentheses, you might think to yourself, oh, that's going to be left because left is a negative direction. But when you look at your graph, notice that it actually shifted your graph over to the right 2 places. Okay, that's pretty easy to see. Now I'm going to actually get rid of this and I'm going to put a minus 2 down here, and you can tell that my graph is shifted down 2. So when it's outside of the parentheses, the number that you see is going to shift your graph up and down. And then if your number is in the parentheses, it's going to shift it left or right. So if you have a negative 2, that means you're going to go to the right 2 places. If I come over here and I have a plus 4, what direction do you think I'm going to go now? Let's see if you're right. I shifted over to the left 4. So when it's in parentheses, it's going to do the opposite of what you think it's doing. It's very similar to when we talk about point slope form and how, like, if in our point we have 2 positive numbers, then in the formula itself we end up with 2 negative numbers. It's very similar. Now, the reason that I'm showing you these changes with x squared and not x is this reason. Although you know it has shifted to the left 4, it also looks like it's shifted up 4. So it's a lot easier to see the changes appropriately with the quadratic parent function, but the actual transformation is still going to be right or left. So when we had it in parentheses, we went the opposite direction. We went to the right 2. So we are going to take our graph and we are going to move our graph over 2 places. So here's that. Here is that, okay? And you may want to draw an arrow to the right so you know which direction you traveled. And then when we were looking at f of x plus 4, when it was in parentheses, we actually shifted to the left 4. So when I typically teach this, this is going to sound really funny to you, but the way that I help my kids remember this, and again, this is going to sound really funny, but there are kids that I have taught like 8 years ago that still tell me that when they have to do this type of thing, they remember what I told them, okay? And what I tell you guys to remember this is when you have something in parentheses, I want you to imagine that you are trapped in a room with your ex. They're going to tell you, hey, I need you to go to the right 2, and you're going to say, I'm not listening to you. I'm going to do whatever I want, and I'm going to do the opposite of what you want because you're my ex and you're gross. And so if they say, oh, I want you to go to the left 2, like it's showing you here, you're going to say, I'm going to go to the right 2. Or if you're ex, you're trapped in a room, and they say, I want you to go to the right 4, you're going to go, I'm going to go to the left 4. These people up here are not trapped in a room with their ex. They are independent and they are going to do whatever they want to do. So if they want to go up 2, that is where they're going. If they want to go down 3, that is where they're going. So these people up here are not trapped in a room with their ex. These people are trapped in a room with their ex. So to help you remember, you might want to put arrows on your graph so that you can kind of see the differences in the directions. And then up here, remember that we went up 2, and over here we went down 3. Okay, so those are your horizontal and your vertical translations. So now let's talk about reflections across the axes. In Algebra 1, we will focus reflections over the x and y axis. To see these reflections happen, we're actually going to use a slightly different equation. We're going to use f of x equals 2x plus 1 instead of f of x equals x. If you look at the 2 graphs below down here, I've actually gone ahead and graphed the 2x plus 1 for you, but I need to change that in Desmos. So we're going to have this as 2x plus 1. And then we are going to make this f of x just so that it's the same for now. Okay. Now, what you're looking at whenever you see a reflection is you are going to see a reflection as having a negative. Now, your negative will either be in front of x or in front of f like you have here. This is not the same thing as a negative after x, okay, or a negative on the outside over here. That's not a negative, that's a positive. This is a negative, okay? The negatives must be either in front of f or they must be on the inside of the parentheses in front of x, okay? That is how you will know whether or not you have a reflection. So let's figure out what reflection we have if the negative is inside with x. I'm going to put a negative in here. Right now, my graph is red. That's my new graph, okay? And I'm going to stick a negative in here. And as you can tell, when the negative is on the inside with x, I have reflected across the y-axis. And you know it's the y-axis because if you look at the y-intercept hasn't changed. But my original graph had a slope of a positive 2, the red graph. And when I reflected it over the y-axis, now my slope is a negative 2, okay? So translations, like we saw before, do not affect your slope. Reflections do affect your slope. So what happened whenever we had a negative? We are going to say that this is a y-axis reflection. And you must put y-axis reflection. You can't just put reflection because there are many different types of reflections. So what happened? Your y value stayed the same, or your y-intercept stayed the same, and then your graph just reflected across that axis and across that point. Okay? And you might want to make a note to yourself. Y-intercept stayed the same, which is how you know it is a y-axis reflection. Okay, so now that we know that, let's make a guess, an educated guess here, a hypothesis, if you will. If the negative is in front of f of x, what do you think is going to happen? Let's check it out in Desmos and see if you were right. I'm going to remove the negative from in front of x, and now I'm going to put it in front of f. And if you look at our graphs, notice that they both share the same x-intercept. That means that our graph has actually been reflected across the x-axis. My slope was a positive 2 over 1, and it is now a negative 2 over 1. So we are going to go back over here, and this was an x-axis reflection. Okay, this stayed the same. Our x-axis stayed the same, so we're going up 2 over 1, up 2 over 1. We went down 2 over 1. Where am I? Down 2 over 1, down 2 over 1. That doesn't look right. Why does this look weird? That's a half. 1, 2. Oh, I need to go over 1. Hee hee. I'm a silly goose. Get rid of that. And then I'm going to go down 2 over 1. There we go. That looks better. And that is an x-axis reflection. So here, our x-intercept stayed the same. And we know that because it's an x-axis reflection. Okay, so those negatives mean reflections. All right, now we're going to move down to stretches and compressions. Depending on who your teacher is will depend on whether or not they require you to say stretch and compression. I do not focus very heavily on stretches and compressions. I focus more on, is your graph getting steeper or less steep, but other teachers do focus a lot on stretches and compressions. So depending on who your teacher is will depend on how like strict they are about this. Even if you are my student and you like knowing the difference between horizontal stretches and compressions, you can always say stretches and compressions, but you need to make sure that you are giving the correct stretch and compression. And the same is true with the other teachers that do focus primarily on stretches and compressions. You have to know what kind of stretch and compression you have, and you have to make sure that you always mention it the right way. So this one's going to take a little bit of time. We're going to do our best. Let's see what happens. Okay. So stretches and compressions, this is also known as steeper and less steep. Okay, the transformation that changes how steep your graph is contains stretches and compressions. To see these changes on a graph, we will use the same equation we used a second ago, f of x equals 2x plus 1 instead of f of x equals x. So vertical changes, so a vertical stretch and compression for me, Mrs. Olmsted, it's much easier for me to see vertical stretches and compressions than horizontal stretches and compressions. And so I think that might be the same for others. Like in my head, when I think of a vertical stretch and compression, it's like you take a person and you stretch them out top to bottom. That makes them taller, so your graph will get steeper. If you take a person and you like push your hands on their head, you push them down towards the ground, they're going to get wider or less steep if they were, a straight line. So if we are looking at whether or not we have a vertical change, you are going to have a number that is in front of f of x. So your number is going to be in front of f of x, okay? If your number is greater than 1, your graph will have a vertical stretch. So it's getting elongated or longer. If your number is between 0 and 1, like 1/2, 2/3, 4/5, something like that, your graph will have a vertical compression. Okay, so let's see what that looks like. Notice that you have a number in front of f of x, a number in front of f of x. Okay, so what we're going to do is we are going to go to Desmos. I already have the right thing put in here. Our original graph is red. Our new graph is going to be green. And I'm going to start by putting 1/2 in front of f of x. And for whatever reason, it's not happy with me right now. There we go. Okay, so when I put 1/2 into Desmos, okay, my red graph got less steep or it compressed vertically. So top to bottom, okay, your graph is being pushed down, so it's becoming less steep. Your slope is becoming less steep. Your slope is basically being cut in half at this point, okay? So notice that your red line is really steep and your green line is not quite as steep. That is going to be considered a vertical compression. So if we go back, remember I said a vertical compression will have a number between 0 and 1, and 1/2 is between 0 and 1. I'm not going to graph it on here. You can graph it on here if you would like, but just know that this is going to be a vertical compression, this is also going to be less steep. Your graph has gotten less steep over time. If we go back and put a 3 in place, that is a number greater than 1, okay? So you should theoretically see a stretch or your graph get longer. Okay, so let's get rid of this. Oh my gosh, my iPad is not having a good time today. Oop. And then your line has gone from being fairly steep with the red one to being really, really steep with the green one. So that is what we call a vertical stretch. My graph is getting taller. It is elongating. So this is going to be a vertical stretch. This is also you getting steeper. Now, both of these graphs did not change their x-intercept because your number is in front of f of x, just like when we did our x-axis reflection, the negative was in front of f of x, and so our x-intercept doesn't change. So this is going to be getting steeper over here. I'm not going to make it perfect. And this one over here, it got less steep. Okay, the x-axis did, or the x-intercept did not change. So when we talk about horizontal changes, instead of your number being front of f of x, you're now going to have numbers in front of x only. So look down here. They were in front of f, now they're in front of x. If your number is greater than 1, your graph will have a horizontal compression. It's the opposite of what you think it is. So horizontal changes are the opposite of what you think, okay? You would think a number greater than 1 would be getting bigger, but in reality, it's going to be a horizontal compression. And then if your number is between 0 and 1, your graph will have a horizontal stretch, okay? So here's a way that you can kind of think about this, okay? You know a horizontal line goes from left to right. If I take, let's say like a piece of gum, okay, and I chew it up and I make it all gross and like squishy, and I pull it horizontally, okay? As I start to pull apart, okay, I'm stretching it, my line is actually going to get less steep, okay, because I'm pulling apart. The graph is expanding, but it's expanding left to right, not up and down, so it's actually getting longer, okay? If I take my piece of gum and I start to squish it back together, okay, it's going to get compressed and it's going to get bigger as I do that. So you're going to have a horizontal compression. And we'll see what that looks like in Desmos. So because these are also in front of x, you're going to see that your y-intercept does not change, similar to when you have a y-axis reflection. So let's go to Desmos, and I'm going to remove that 3 in front of f, and instead, what number did I have? 1/3? Can't see. 1/3. 1/3 and 5. Okay. Whoops. Ah. Let's do 1/3. Okay. So it looks like my graph is getting less steep, and it technically is getting less steep, but mathematically, this is also known as a horizontal stretch. Okay. If you know what it is as a vertical change, then it's just going to be the opposite when you think about it as a horizontal change. Okay. So this is going to be a horizontal stretch. Okay, it would be a vertical compression, but a horizontal stretch. Your y-intercept is not changing. However, my graph is still getting less steep. So when your numbers are less than 1, your graph is still getting less steep. If I go back in here and I put a 5 in there, you're going to see that my graph is getting steeper, but my y-intercept has not changed, but that is known as a horizontal compression. Okay, so here we have a horizontal compression, and your graph is getting steeper. Y-intercept has not changed. Mommy. Hi, baby. Mommy's making a video right now. Nope. I need you to go talk to Daddy. Thank you so much. I'll be out in a second. I heard you. Yep. Thank you so much. Can you go back out there with Daddy? Yeah. Okay. Thank you. Love you. Can you close the door? Okay. Thanks. Bye. Leave and then close the door. Okay. I love you. Bye. Mommy. Yes, baby. Bye. Love you. All right. So now you could in theory, graph this every time to see what the changes are. However, I want you to try to be able to do this without having to graph things. So we want to focus really heavily on the changes that we're seeing with our transformation equation, and just automatically be able to see it and go, oh, I know exactly what's happening. I don't even have to graph it. I just know. Okay. So we talked about an example of each of these. Now, as we talk about it, some of these are going to have more than one transformation happening at a time. Okay. So before we get started, down here, we have this summary, and this summary is every single thing that we just talked about. So I'm going to actually start down here. Okay, these are the very first two things that we talked about. When you see this, okay, this is when you go up, a shift up, and this is a shift down. So this is earlier on in our notes, we had a +2 and I think like a -3 at the end. Okay, so that's going to be a shift up and a shift down. When you are inside of the parentheses, remember, this is the same thing as you being stuck in a room with your ex. They're going to tell you to go one way, and you're going to go, I'm going to do the opposite. So this is actually going to be a shift left, and this is going to be a shift right. So these four right here, I'll write this in black. These are translations. Okay, those are translations. As we move over here, okay, we have these two things. These were our reflections. Your options are only an x-axis reflection and a y-axis reflection, and it really just depends on where your negative is located. What did I do this in? Did I do this in purple? Okay, I did this in purple. So when it is in front of F, that is an x-axis reflection. When it is inside of the parentheses with X, that is a y-axis reflection. And then lastly, we have compressions and stretches, okay? If you have a number in front of A or in front of F, these are going to be a vertical change. So this is a vertical change. And then if you have a number inside with X, that is a horizontal change. Now, if your number, if A or B is greater than 1, okay, then it's either going to be a vertical stretch or a horizontal compression. But either way, your graph is getting steeper, okay? If your A or B value is between 0 or 1, it's a fraction, 1/2, 2/3, 4/10, something like that. This is going to be a vertical compression. This will also be a horizontal stretch. And both of these mean that your graph is getting less steep. Okay, so again, depending on who your teacher is, will determine whether or not, or how detailed you have to be. Because I make this video for everybody, I'm going to be pretty detailed in it. But in class, I'll let you know how detailed I want you to be. Okay, let's start here with number 1. We have a negative in front of f of x. I'm just going to do everything in pink. Why not? If you have a negative in front of f of x, this is an x-axis reflection. I don't have to graph that. I just automatically know that that negative is an x-axis reflection. As I move over here to number 2, I have this +4 at the back. It is not in parentheses, so I know that that's going to be a shift up or down. Because this is not in parentheses, this is the independent person who doesn't need anybody else to tell them what to do in their life, and they are going to shift up 4. It is imperative that if you have a translation like up, down, left, or right, that you tell me how many places your graph is shifting. But if it's something like a vertical stretch or compression or whatever, you don't have to be super detailed in that matter. At least for Miss Olmsted, I don't know how your other teachers are going to want you to do that. All right, here we have a number inside of the parentheses. Because it's inside of the parentheses, we already know it's going to be a horizontal. Because the number is greater than 1, that is going to be kind of the opposite of what we want it to be. Because the number is greater than 1, we think that it's going to be stretching, but with horizontal, it's the opposite. So this is actually a horizontal compression. Moving over here, I actually have two things that are happening. I've got my negative, which is one thing, and then I have this 0.3, which is another. The negative on the inside, it is in front of X, so this is actually a Y-axis reflection. And then this 0.3, that is a number that is less than 1, and it is inside the parentheses in front of X, so that means that it's going to be a horizontal change. Because it is a number that is less than 1 but greater than 0, this is actually going to be a horizontal stretch. I should have mentioned this earlier. This is a horizontal stretch. This is also going to be something that is less steep. And over here, this is a horizontal compression, and this is actually going to also be your graph getting steeper. Okay, so now we're moving into having maybe more than one thing that's happening. More than one transformation. All right, here we go. We have a 3 in front of F. So because it's in front, we know it's going to be a vertical change. And vertical changes are exactly what you want them to be. It is a number greater than 1 because it is in front of f of x. It's going to be a vertical. And for us, it's going to be a vertical stretch. This is also our graph getting steeper. All right, I have two things happening here. I have this thing that's in parentheses, and then I also have this thing that is not in parentheses. This is actually going to be right 2. There is no reflection because the negative is after the x. After the x is not helpful to us, okay? That is no reflection. It has to be in front of x or in front of f for there to be a reflection. And then that's in parentheses, so it's going to do the opposite of what its x wants it to do. And then this positive 6, it's by itself. It's independent. It can do what it wants. It's going to go up 6. All right, here we have a negative on the inside of our parentheses, and then we have a 2. The negative is going to be a y-axis reflection. And this 2, because it's on the inside of the parentheses, it is going to be a horizontal change. Because that number is greater than 1, we want to think stretch, but because it is in the inside and it's with horizontal, it's going to be the opposite. So this is a horizontal compression. However, my graph is actually still getting steeper. All right, number 8. There are 3 things happening here. We have a negative, we have a 5, and we have this plus 4. The negative is on the outside of F, so this is going to be an x-axis reflection. The 5 is in front of F, which means it's a vertical change. And it's going to be the change that we want it to be. This is going to be a vertical stretch. This is also my graph getting steeper. And then the plus 4 is not in parentheses. It's independent, so it's going to do what it wants. It's going to move up 4. So notice as I do this, the only thing that's ever left untouched in all of these is the F and the X. That's it. Everything else has to have has to be something, okay? Oh, this one's boring. This is a negative on the inside of the parentheses in front of x. This is just a y-axis reflection. And then the big mama of transformations. We have 1, 2, 3, and 4. I always start at the left. The negative on the outside means that I have an x-axis reflection. The 3 is on the outside, which means it's a vertical change. Because it's vertical, it does what I want it to do. So this is a vertical stretch. This is also my graph getting steeper. This is inside of the parentheses, so it's going to do the opposite of what its x is telling it to do. So that means we're going to go left 1. And then this positive 2 at the back is independent. It is going to go up 2. So notice that I was able to do all of this without having to graph it. I can just know based on the summary down here of what all of these different symbols mean. Okay, so that is everything I have for you. If you have any questions over transformations, go see your teacher during their normally scheduled tutorial times. And that's all I got. All right, I will see you in the next video. Bye-bye.